Alright guys, want to document for you and for me setting up the tailstock quill to bore the end for the Morse taper insert. So I've decided an idea, maybe not the greatest idea, but an idea is to set it up in the actual Hendey lathe itself, okay? Because that's the steady rest I had over in the the Colchester 17, but it is made for the Hendey. I bought this on eBay for $100. The guy didn't know what it was, what lathe it was for, and I got this years ago. But it's made to fit the Hendey, so I have a nice steady rest for the Hendey, which is awesome because I'm trying to use it here. So again, the reason I'm trying to use the steady rest is because this is the only way that I have to accurately bore this straight, to center it straight. Because every chuck that I have seems to have not only radial run out, but angular run out. The jaws are not true. They're not straight with the bed. They're not straight with the spindle center line. They're off a little bit. Now, because a steady rest has these bronze fingers, if you ride on the shaft, it spins as true as the shaft is round, okay? Which is great. You have intrinsic centering running true axially on the shaft when you use a steady rest. Now, as I explained before, I think I did, because the keyway, I was not thinking ahead, and I cut a keyway in the shaft for the anti-rotational feature of the tailstock. So I got this bushing. It's just a piece of steel, and I turn the inside and the outside in one chucking. What does that mean? If I turn the inside and the outside in one chucking operation, which means, you know, grabbing it in a chuck, both features will automatically end up concentric and parallel with each other because you didn't disturb the mounting of the piece in the chuck, in the lathe, whatever. So as you know, the tailstock quill is 1.5 inches or a few tenths under. So when I bored the steel bushing, I left the inside diameter 1/2 thousandth or 5/10 undersize. So then I honed it to fit exactly a line-to-line fit with a brake cylinder hone. The 3-finger abrasive brake cylinder hone made for doing wheel cylinders and calipers on cars and whatever. So that thing fits on there. It's line to line, which means you can hardly get it on there. You know, when you're trying to slide it on, you're constantly trying to get it straight, and you're fighting a crook, but it's on there. And so now I'm running the fingers on this bushing to jump over the keyway, right? I don't say things in the right order sometimes. Because the keyway's in the shaft, those little fingers would just fall into the keyway or make a hell of a badoink going over it. So that's the reason for the bushing. Okay. What's going on with the post-it notes, Doozer? This is a brand new chuck. This I bought on eBay a while ago. I got a good deal on it. I think I paid $100 for it, or $125. I think it was $125. Brand new, Farida? I don't remember the name. I think it's a Chinese chuck, but it's pretty well made. Well, anyways, the paper's to protect the finish of the shaft, and it's also, I think this had about, I don't know, 4 thousandths of run out, something like that. So I shimmed it so this end runs true. You do what you got to do. A 4-jaw would have been better. I have a 4-jaw for this, but it's not on the back plate, backing plate. So I just shimmed it, and I protect the shaft. I would shim a 4-jaw to protect the shaft regardless, you know? All right, so how do you get this straight? Well, this is a Starrett base of some kind. I don't know the number. It's probably impression stamped on there. Looks like a little I-beam with T-slots. Kind of a neat deal. It's just a heavy dial indicator base, okay? So I'm set up with an indicator. This is that... These are cool little magnet bases with the flexible, they're like Noga arms. These say HG. HG stands for Hoffman Group, and they're only available in Europe. What's his name there? Steven Goatswinter has 1 or 2 of these himself, because obviously he's in Germany. I snagged this one and another one on eBay. And I got it set up with the Federal indicator. These are nice, small, this is the smallest series that Federal makes. And I got a little adaptation there. The nice about these is they're a plunger indicator. They're a straight in and out indicator. So there's no cosine error with the tip of a test indicator. Let me go around the back side. You know what I mean. If you're going to use a test indicator, what's this one? Inter-rapid, but you know, you always have some error with the needle because it's a swings in an arc. It's not a plunger in and out. Okay. All right, I am behind the lathe. I am behind the lathe. In between 2 lathes. Right? Oh, that's tight. Story of my life. Okay, so this Starrett base is riding along the edge of the prismatic inverted V-way. Just that, you know, straight portion. Okay, so you'll notice that this, I'm zeroed out at 70, okay? And I'm riding along the top, just next to that keyway. So I'm going to grab this, I'm going to move it down to, let's say, there. So now I'm at the chuck end. Focus, you freak. And I'm still at 70, which is great. And then if you look at, well, I'm at 0. Okay, that's 0. That's where I was, right? I'm gonna move it down. I put some oil on the bed and it's awful stick slippy. It moves around a little. There's a little bit of a bow regard in this. I can't see. So it's 0 again, right? And there's a little bit of a bow in here, not anything appreciable, but I'm running. These are both checking radial run out. Radius meaning, you know, from the side. So I'm checking the radial run out at the top and checking the radial run out at the side. And what I did is I adjusted these fingers. You know, let me stop again. If these fingers are completely backed off and this thing was just sticking out here in free air, in God's blue sky, the run out on this indicator was only like 2 or 3 thousandths, right? And that's pretty good. Maybe it's 3 or 4, I don't remember. But having, you know, a 20-inch shaft sticking out this far, to be running out only, you know, 3 or 4 thousandths is really good. So I'm not fighting the jaws being out here. These jaws are pretty darn good. It's a brand new chuck. It's never been used. I mean, who's to say what the quality and accuracy is, but it's pretty good. But you need this steady rest, obviously, to make it rigid, right? So I explained all that to say that I'm not forcing the shaft into alignment by very much, maybe 3 thousandths, 4 thousandths at most. So I'm not forcing this shaft into alignment, into a center coaxial with the spindle rotation situation. I'm not. So again, I adjusted the top, and I brought this right at 0. I mean, it's at 70, but that's my 0. You know, I zeroed it, the vertical, using the top adjuster screw, and then there's 2 at, you know, 1/3 increments on the bottom, and I just played with the bottom until I got the side indicator to read 0. So that's it. By just making up a sled with that indicator base, it's like a surface gauge application is kind of what I'm using it for. But this is a little bit nicer than a surface gauge because it's bigger, you know, right? Okay. Let me sneak out from behind my lathe again. Very sneaky. So anyways, you see I colored this end with magic marker because it fit the best, being at the taper, you know, the working end of the tailstock. It's like in the hospital. The guy needs a leg amputated. They draw a magic marker X on his bad leg that needs to be amputated because you don't want to cut off the wrong leg. It's happened apparently. So I marked that end to make sure I install the socket at that end, and I'm going to flip it and do this again and install the bronze nut, the Acme nut, at this end. So that's my setup. That's how I'm trying to assure alignment and accuracy. This is the best way I can come up with. It would be nice. See, they have gunsmithing lathes, and I always wondered, what's a gunsmithing lathe? Well, it's like a mini oil field lathe, where a gunsmithing lathe is typically the headstock is shorter. They're about, you know, a foot. This thing's about 2 foot. And they have a chuck on the other end. Or not a chuck, but a spider with those four set screws, like a very rudimentary 4-jaw chuck, to center up both ends of your gun barrel or whatever. But that would be handy for this. But if you don't have one of those gunsmith type lathes, oh, this is just a sexy beast, isn't it? It's just a really great looking lathe. Then you use a steady rest on the bed, and hopefully your bed is long enough. This one's almost not long enough because I got to set up a tool post. I got to bore 3 1/4 inches deep or something, and I'm right touching the end of the world here. This is the end of the travel, and I could put this down deeper in the chuck a little bit if I wanted to, if I absolutely cannot swing it this way. But that's my setup for indicating. All this precision stuff that has to be within less than 1,000th takes so much time. But if you're making parts for a lathe that needs to be accurate, you need to be super accurate on the parts you're making, especially something like this. All right, I've talked too much. Thanks for watching. This is Doozer Shop.